All right, welcome to today's class, Logarithm Part 2. Logarithm Part 2, which is actually a continuation of Logarithm Part 1. In Logarithm Part 1, we treated the laws of logarithm and then we also solved an example. So here we want to continue from there, Logarithm Part 2. And we have just two examples. If log x squared base 10 is less than or equal to 2 plus log y base 10, express y in terms of x. Express y in terms of x. That is, make y the subject of formula. All right. So let's see how we can handle that. This will be log x squared base 10 is less than or equal to. Recall, if you go through logarithm part 1, that's why I would advise, if you have not gone through part 1, please go through part 1 before coming over to part 2. Under part 1, we treated the laws of logarithm. And then we said the first law, either you call it addition or multiplication law. The law only works when the bases are the same. So what we have here is 2. We can express it in the logarithmic form. As it is, you cannot add 2 plus this because this is a number while this is in the log form. So 2 is the same thing as log 100 base 10. Now, why is it so? The base here is 10. So I need to keep this number with base 10. If you go through part 1, I explained that the log of a number, let's say, uh, log 27, the log of a number to any base, let's say base 3, whatever it will give you as the answer is simply the power to which this base must be raised to, so as to have this number. Log of a number to any base, the answer is simply the number that this base must be raised to, so as to have this. So it simply means that this is equal to 3. Reason, 3 raised to power 3 is equal to 27. And if you have something like this, let's say log 81 base 3, the answer is simply 4. Why is it 4? Because the base raised to power 4 will give you 81. 3 raised to power 4 is equal to 81. So we call this the logarithmic form and we call this the index form. So from there, you can see that 2 is the same thing as log 100 base 10 because 10 raised to power 2 is 100. And so plus. Now, if this were to be base 5, that means I will express this as log 25 base 5. So I'm keeping it in base 10 because what I have is base 10, what I have is in base 10. I want all of them to be in the same base. All right, plus log y base 10. Okay, now, still under the laws of logarithm, we said when the bases are the same and it is addition, you can multiply the number. When the bases are the same, so this is log 100 base 10, log y base 10. The bases are the same. So this will give us log x squared base 10 is less than or equal to log 100y base 10. Why is it so? Addition, or we call it multiplication law. When the bases are the same and it is addition, you multiply these numbers. So that's the law that I applied there. And if you also look at this, the base in the left hand side is 10, the base in the right hand side is 10. So it therefore means that x squared must be the same thing as this. So less than or equal to 100y. And now we were asked to express y in terms of x, that is, make y the subject of formula. So the only way this y can stand alone is by dividing both sides by 100, so that it will cancel out and y will stay alone. So if I divide both sides by 100, I will have x squared over 100 is less than or equal to 100y over 100. And this will cancel out, so you have x squared over 100 is less than or equal to y. Now that's the answer, but if it is an objective question, you may not see this in the option. So there's another way of expressing it. Now before I show you another way, let's look at this. If you have 10 is less than 30, if I express 30 first, it will now be 30 is greater than 10. Take note. This is 10 is less than 30. If I express 30 first, the sign will change. But if it were to be equality sign, it will still be the same thing. For example, if you have x is equal to 5, it's the same thing as saying 5 is equal to x because that is equality sign. But in inequality, it is not like that. So for expressing 30 first, the sign will change to greater than. So I will apply that here, which means that, like I said, if it is a theory question, even if you stop there, you are okay. But objective, this is another way of expressing it. Y is greater than or equal to x squared over 10. Sorry, x squared over 100. That's it. So that answer is correct. Another way, you can still keep it like this. X is greater than or equal to, or sorry, y is greater than or equal to x over 10 squared. So you keep it like this, you're okay. Keep it like this, you're okay. Keep it like that, you are still correct. So with that, we are through with number one. So let's look at number two. Let's quickly look at number two. As far as this topic is concerned, you need to know the laws of logarithm because for every question on logarithm, it will always resemble one of the laws. When you look at a question, just think which law does this question resemble, then you apply the law. It must always resemble one of the laws. So if you look at number two, we are told law 16 base root 2 is equal to x. Now we want to find the value of x. I'll quickly use two, okay, because of, okay. I can use two methods to solve this. You arrive at the same answer. There are many ways. So, first of all, you can change it to index form. Use that idea and solve. You can change it to index form. Remember I said, if you have log n base a equals alpha, this is called logarithmic equation. While in index form, it will be a raised to power alpha is equal to n. So this question is in logarithmic form. You can change it to index form and solve it. There is no problem. Or you can still use this approach. Laws of indices, x raised to power 1 over n is simply equal to the end root of x. So the square root of 2 here simply means 2 raised to power 1 over 2. Meaning, I can express that question like this. Log 2